Here we will take a look on how to create a SolidWork model to simulate a heat transfer problem in this Manzanares power plant. So we will try to simulate this heat transfer in CFD software. Now, this is the layout of the power plant. So there is a collector here for collecting heat. We got a chimney, very long chimney for generating airflows. Now there is the turbines beneath the chimneys, and this is to generate electricity. So to simulate this one in CFD, we have to simulate the entire systems. So the key component here are actually the turbines. So in CFD, we have to simulate the rotation of these wind turbines. So this means that we need to separate these turbines from other components. We have to create a zone, a rotating zone, to take into account the rotations of these wind turbines. So this means that we can split this entire power plant into 3 different regions. One region for the collectors, so basically everything is under these wind turbines, and then one rotating region for these wind turbines, and lastly the third regions for the chimneys. So this means that in SolidWork we have to create 3 components. One component for the collectors, one component for the wind turbine, and lastly one component for the chimneys. So we create these 3 components, then we combine it in our assembly in SolidWorks, and before we export it to your CFD software for further analysis. So how do we create these solar collectors? For the first component, we need to create these collectors based on the specification given here. We've created collectors. Now also we have to create the base for these turbines, right? So these are the key components. Basically, we need to create everything that is below this turbine zone. All right. So if you open out your SolidWork, so we can go to the front plan and sketch. So there's 2 components that we need to create. One is the base for the turbine. So the base is 10 meter. So first you can go to option here and change the units to meter kilogram in seconds. So this is already in meter kilogram in seconds. Now we can create from the origins so this is 10 meter. So the base of the turbine is 10 meter, and it has a certain width, and that is 0.8 meters. So So the diameter of the chimney is 10 meters. So this means that the radius of the chimney will be 5 meters. All right. So we create this one, a line to represent the radius of the chimneys. Now we create. So we created collectors now. So the collectors is some distance away from the chimney. It's 13 meters. And the collectors has the mean height of 1.85 meters. So we can use a rectangular here to create your collectors. So it has the length of 109 and the height is 1.85. So this representing your collectors. Now the base of the turbine will be connected to these points, and you can use curve. We can use spline to connect from the tips of this turbine base to your collectors. So we can adjust actually the shapes. There is no definite actually configurations to the shape of this turbine base. So you can just adjust the spline so that it will look closely to what a turbine base looks like. Now there is also a curve that connects the chimney to these collectors, and we can again use spline to connect these two dots and adjust the shapes so that the curve looks more natural. So this completes the this completes actually the drawing for the base, for the collectors, as well as the base of the chimney or the turbine. Now we can use revolved surface to create the 3D representations of these collectors. So now I see the sketch and revolve the surface. And this 360 degree. the axis would be this one. So this generates the base and the collectors. This is the first components. Now we move on to the second component, creating the rotating domain for these wind turbines. So before we proceed to create your wind turbine, we need to know what is the shapes of your turbine blades. So this is the shapes of the turbine blades from Manzanares power plant, and you're able to get these shapes from this particular website. This particular website able to provide you the data to create these aerofoil shapes in your SolidWork. So there are 4 blades for these power plants, and the shapes and the size, the orientations of the aerofoils actually changes along these the length of the turbine blades. So here there is information showing how the size and the orientation changes along the at different positions along the length of the blades. So there is a twist here, how the orientation changes at different positions, and the chord is showing how the size changes along different positions. So the scale here is showing how the size of the aerofoils relative to the chords at the base of your turbine blades. So in SolidWork, we actually need to create this aerofoil at different positions along these turbine blades before we connect them together to generate your final turbine blades. Now we create a new component called turbines, so that we can create this rotating zone for your turbines. So here, the very first thing, we need to create a plane. So we can select front plane, and based on front plane, we can create a plane. Now this plane is 0.8 meters, 0.8 meters away from your origins. So this is where where your turbine blades begins. So next step is to create a curve. So this is the data from the website. And the website assuming that the chords has the dimensions of 1 meter. So based on this curve, we can create our first aerofoils at the first plane. So we go to your plane here, and we click convert entity, So now we have this aerofoils on our planet. So next step is to scale it. Scale and also rotate. So this original aerofoil has a chord of 1 meters, and we need to scale it to the actual size, which is 0.4682. So select scale. So this creates an aerofoil with the shape that we want. Obviously, we need to also twist it by 13.72 degree. So select this entity and rotate it. So this creates the aerofoil that represents the configurations of the actual turbines. Click OK. So we can hide this one. Now we might need to move. So this is your origin. We might need to move your aerofoil to the middle of the chord. So we can do that. We can shift this entity. Or minus 0.2. And this places our aerofoil somewhere in the middle of the origins. When we exit, we will have your plan number 1. And we need to repeat the same process. For your second plan, so this basically your second plan will have the same aerofoil as the first one. So what you can do is you create a new plan as well based on the front, and this will have the positions of 0.93. So create a sketch. and convert this entity. Select OK, and you have the aerofoil second plan. So the third one will be at 1.075. We'll have a different twist angle and different chord. We need to repeat the process again. Select your front plan. Just let's see the sketch first. Select front plan, create a plan. That is 1.075. Click OK, and you might need to unhide this one. Sketch the plan number 4. So convert this entity. Yes. Now scale it. Scale it by 0.4245. Rotate it by this amount. And remember, finally, to also move it by 0.2 meters minus 0.2 meters. Now you have the aerofoil at the third plane, the third positions. So we have to actually create more. Repeat the same process for the rest of the positions. So exit the sketch, click front plane, click plane, yes, and click sketch, convert this entity, and again scale it by 0.3646. 3646. Rotate it. By 8.78. 8.78. And finally, remove it. Together. And you have your aerofoil at your third positions. So we need to repeat the same process for the remaining positions. Once we complete it, all the aerofoil, we will have distributions of aerofoil that looks like this. So the next step is to connect all the aerofoil and create a volume. And to do that, we will use a function called loft base. So before we proceed to create and connect all the aerofoils, we need to create a guide. So we can create a guide that allows us to connect all the aerofoil more easily. So we use this 3D sketch, spline, and use this spline to connect this aerofoil together. So we can select all the surfaces. So we created our aerofoil. To create 4 blades, we can use circular pattern. Once we created this blade, we need to create the center of this turbine blade. The center of turbine blades that connect all 4 blades together. So go to your top plan and sketch. So he has a radius of 0.8. This is the radius of the turbine base. So your aerofoil is slightly offset and you might need to move. 0.2, 0.8. Now extrude. This plan. Extrude both sides, and this would be the thickness of your rotating zone, 0.4 meter, and now you have the center of your turbine blades. Next step is to create the remaining turbine blades using these circular patterns. Equal spacings, you're gonna have 4. It's 90-degree. Select body. So you have the complete aerofoil. Turbine blades with aerofoil. So the next step is actually create the rotating domain of the fluid. So in order to do that, we need to create a body that represents the space, the fluid, of the fluids, and then take that body, subtract it from the turbine blades as well as the center. So we go to our top plan again, sketch, so this is 5 meter or smaller. Eight. Based on this sketch, we extrude again. With the same size as the center of the turbine, same height. Now to create this rotating zone, we simply use the functions called combine. So here we combine. We take the main body and subtract from the turbine. And now we completed the domain for your rotating turbines. So this represents the domains of the fluids in the rotating turbine regions. The final component that we need to create, it will be the chimney. So this chimney, the last component, will be resting on your rotating zone. So this chimney, it would have an interface with your rotating zone. So the total height of the chimney is 200, which means that if we minus the height of the base of the turbine 10 meters, so the height of the chimney component will be only 190 meters. So here on your SolidWork, go to your front plane and create. Go to your top plane and create sketch. So this, when we creating this, it represents the fluids domain inside the chimney. Now we need to bear in mind that the bottom of the chimney will be interfaced with your rotating zone. So which means that we need to create a surface that can match your rotating turbines. This means that we need to create actually two cylinders, one for the interface that is not rotates and one for the interface that is actually rotating. So the one that is not rotating, the one that is rotating would be between 0.8, radius of 0.8 and radius of 5 meters. Now we can extrude this for 190 meters. So this gives us a cone that is hollow inside. Now we need to create actually another extrusion of cylinders, and that cylinder will be needed to create a boundary for the zone that is not rotating. So we go to top plane again. Top plane again, we create sketch. This is the second sketch. And create cylinder. 0.8. We can extrude this one. So we're gonna have two cylinders. So this completes our last component. For the solar chimney power plants, the next stage is actually to assemble all your components together before we're exporting to your CFD software. Now on our SolidWork assembly here, we got three components that we just created. So first we can import our collectors. We make it flat, the collectors. And we can move it to the locations that we want. In this case, we're going to place it at 0, 0, 0. So your collector now is positioned exactly at the origin 0, 0, 0. Now we can proceed to insert your turbine. Your turbine will be located at the top of your collectors. So this is going to be 0, this is going to be 0, and then for 4, where it is a slight misalignment. Now it matches perfectly. So finally, add your chimney. And your chimney gonna place right on top of your turbine. This will be 0, this will be 0. This will be 10.4. So you assemble your solar chimney. Now you successfully assemble all the components of